Note 6, page 1, we're still working with simplifying with negative exponents. Things to remember, all exponential rules stay the same, whether it's a positive or negative exponent. Unless otherwise stated, you should remove negative exponents from your final answer. And you remove negative exponents not by simply erasing them, but by doing what the exponent tells you to do, that is, take the reciprocal of the base. So there's more language that would be very helpful. I mean, you really need it. When you see a negative exponent, you should be thinking, oh, I'm taking the reciprocal. So rather than saying, oh, that's -1 exponent. No, that means take the reciprocal. And then finally, remember when you take the reciprocal stays in the original term. So because of that, when you have a problem that's all one term, life becomes easier because any reciprocal you take is going to stay within this one term. You do need to follow order of operations here. And notice for this problem, there are no fractions. And I suspect fractions aren't your best friend. They do complicate things. So don't create one until you have to. Eventually, at some point in time, we'll have to, but I'm not going to start flipping right away. Not going to flip that right away. Not going to do it. I don't want to make this look uglier. So I'm going to follow order of operations using my exponential rules. It's this times the square here. So I need to square this product. That's all factors. So I can distribute the square to each individual factor. So it's going to be -2y to the -1st times whatever comes out when I square this factor. So 3 squared is 9. X to the -2nd squared, that's power to a power. It doesn't matter if the exponent's positive or negative. You multiply the exponents. That's x to the -4th. Y to the 5th to the 2nd, that's power to a power, or if you like piggybacking exponents, again, have language for what you see. You multiply the exponents, that's y to the 10th. Then, again, I'm not going to start flipping right away. I'm going to simplify if I can, and then I will flip at the very end. If I have to create a fraction at the very end, that's when I'll do it. So, -2 times 9, that's just -18. There are no other x's, so that's x to the -4th. And then y to the -1st times y to the 10th. That is multiplying the same base. It is long distance multiplication, but you are multiplying the same base. So again, language for what you see in the problem. Oh, I'm multiplying the same base. What do? Add the exponents. So that's y to the 9th. It doesn't matter if your exponents are positive or negatives or cows or pigs. If you're multiplying the same base, you add the exponents. Now, I really can't simplify any more other than getting rid of the negative exponents. At this point in time, I say, hey, you know what? This means take the reciprocal of the base. It will become the denominator of this term. I am staying in the original term because it's all one term. And there you go. Okay. Now, notice, the thing with negative exponents is you can make your life so much harder than it has to be if you don't learn the most efficient ways to work with these negative exponents. So I will get students who do this. They'll say, oh, negative exponents, that means take the reciprocal. So they immediately take the reciprocal of the y. They immediately take the reciprocal of the x squared, which is not wrong, okay? But then you have to deal with those fractions. Well, that's -2 over y. This is 3y to the 5th over x squared. Now I have to square a fraction. Anyway, you get to the right answer, but it's generally more complicated. So, I mean, the rule of thumb is going to be, if your problem does not have any fractions to start with, just use the exponential rules, use your order of operations, simplify, save the removing of negative exponents to the very end. Okay, so let's look at the next problem. And pretty sure there's probably something like this in a challenge problem or on a graded assignment. But don't freak out. Notice there's two terms. It's this answer minus that answer. You simplify within each term first. So when I get this answer, as I'm working on this answer, it really has nothing to do with this answer. So I can think of this as two separate problems, which each term doesn't look that bad by themselves. One thing you want to notice right off the bat are the signs. Do you see how that's a double negative? I would get rid of that right away. It's minus the opposite of that term, so I'm going to just do that right away so I don't mess up my signs. So that's plus 2 over x to the negative fourth, y to the negative second. Now, here, when we're simplifying each term, it's already a fraction. So, if you already have a fraction, you could go ahead and flip first. You don't have to, but you could go ahead and flip first because you're not creating a fraction that wasn't there. And so in this case, that's what I'm going to do. This is all one term. So when I take reciprocals, I take the reciprocal within the same term. So the 2 to the negative third goes down to the denominator of that term as 2 to the third. The x to the negative fourth goes up to the numerator of that term, and then the y squared stays put. Plus, now this is a totally separate term, but this is all one term, and I can go ahead and take reciprocals. The 2 is not going anywhere. There's no negative exponent. The x to the negative fourth, I take the reciprocal. It goes to the numerator of that term as x to the fourth. The y to the negative second goes to the numerator of that term. And then the only thing left in the denominator is a 1, which we'll get rid of. We don't need it. But notice, by flipping and getting rid of the negative exponents first, I didn't create fractions. I actually made my fractions look easier. So quite often, if your problem starts with a fraction, it can be easier to flip first. But if your problem does not start with a fraction, don't create one until you absolutely need to. All right, so let's go back to this problem. 2 to the third is 8. So this is x to the fourth y squared over 8 plus 2x to the fourth y squared. And it turns out, now that I've simplified within each term, I see that these are like animals. So let's not forget there's an invisible 1 here. And let's not forget, this is the coefficient of this term. I have 1/8 of these x to the fourth y squared kind of guys over here in this pile, and I have 2 of the same thing in this pile. And let's do easy arithmetic. That means I have 2 and 1/8 of these guys. Well, mixed numbers as coefficients, just not good for them. So 2 times 8 is 16 plus 1, that is 17/8. So an improper fraction is better form. That's 17/8 of an x to the fourth y squared. Okay. And if you really wanted to go and take more steps, you could realize that 2 is 16 over 8. So you have 1/8 plus 16/8. You have 17 x to the fourth y squared over 8, which is, by the way, the exact same answer. The coefficient in both of these terms is 17/8, no matter how you write it.